Here we have section 12.6, bearing surfaces. Now the first point is very important. It says, unless special confinement reinforcement is provided, the design bearing stress at a concrete surface shall not exceed 2 formulas for a bearing capacity. So what they're saying here is if you don't have legs here, spaced to that in the special confinement design zone, as in section 10 of the code, then you must design to this criteria. However, for a lot of people, to be safe and more conservative, this is a necessary check in addition. So first of all, you have the equation either phi 0.9 f-c times square root of A2 on A1. That's 1. 2 is phi 1.8 f-c. So what we're going to get into now is what governs both equations. So obviously the strength of concrete, and here the function between A2 and A1. So A2 is the largest area of the supporting surface that is geometrically similar and concentric with A. So what they actually mean here is, there's a look for a ruler. What they actually mean here is largest area geometrically similar. So you have to make a shape similar to this in the length to breadth ratio. So this here, which is the column, that is actually A1 because that's the bearing area. Here we have a slab edge. So this is more critical when we are close to a slab edge. So now calculating the A2 dimension, this will make it geometrically similar. And in the other direction, we have it like this. So that what our A2 will begin to look like is something like this. So taking the dimension at both angles like that, and then calculating an equivalent area, that will give you a shape geometrically similar. As you can see here, if we move the column closer and closer to the edge, the A2 will be much shorter. So what this is saying is the first equation, which is phi 0.9 f-c A2 on A1, as this moves this way, A2 gets much bigger, and this one is more critical than the phi 1.8 f-c. So let's assign some values now and do a computation. So here we have a 300 by 250 column as the A1, and then the A2, which goes out to the slab edges, we've got a 1380 by 1150, which is geometrically similar. So phi for always for compression is 0.6, so 0.6 times 0.9 f-c times square root of 1380 times 1150 divided by 300 times 250, or 0.6 times 1.8 times f-c. We'll keep it as f-c. So what we get here is 1380 times 1150 divided by 300 times 250. That's the A2 and A1, which is significantly large. Square root of answer times 0.6 times 0.9. We end up with 2.5 f-c. So and then on the other side we have 0.6 times 1.8. 6 times 1.8 equals 1.08 f-c. So here we have it. As A2 gets smaller and gets to the edge, if it's on the very edge of the surface, A2 and A1 equals 1, and then all of a sudden this value is significant and works out to be very critical. She'll be right.